Greetings to all my viewers. My name is Darshana Segde. So currently I'm pursuing my master's in IIT Kanpur Aerospace Department, specialization in US program unmanned aerial system. So my topic on the Simulink Student Challenge 2024 is operation of double acting cylinder using 4x3 direction control valve and an accumulator. So coming to the problem statement, as mentioned, using Simulink, we need to create a simulation model for the operation of the load or using 4x3 direction control valve as given in the schematic hydraulic system. So there are a few conditions I have taken here. So a single phase electric motor drives the variable pump, which generates a flow of 100 liters per minute and is capable of generating maximum pressure of 200 bars. So developing a Simulink model for the operation of accumulator, and this Simulink model needs to be executable stage-wise. So coming to the components used, the variable first is a variable displacement pump, enabling the variable flow rates in the system. Second, coming to the ideal angular source, which is used instead of a motor to drive the pump, and the flow rate meter, which is used to visualize or enable to mention the flow rate of the hydraulic fluid. Then comes the differential pressure gauge for the difference in pressure between the 2 points, telling us the difference between the pressure between 2 points. Coming to the hydraulic reference, this is used instead of the reservoir to measure for preserving the system's performance at a specific pressure and pressure relief one. So when a pressure is exceeded beyond its limit, this PRV ensures that the flow is taken back to the reservoir or the hydraulic reference. So coming to the double acting cylinder, this is the main purpose here for loading and unloading or retracting for the position of the cylinder. Next comes the orifice. So orifice is a device. So orifice is a device commonly used for the model flow restriction in the fluid system. Next comes the accumulator. The accumulator used here is a gas type accumulator. So this ensures that the pressure excess of pressure is being kept in the accumulator and is released whenever it's required, devoid of the pump. Next comes the spring-loaded check valve. Ensure the flow is taken in just one direction. Hydraulic fluid can be different types of fluid that is used. The common one is the Skydroll 5. Next comes to the solver configurations. And now a 4x3 direction control valve, ensuring the flow occurring between from the accumulator to the double acting cylinder and then towards the hydraulic reference. So this is the hydraulic circuit diagram in Simulink model as per the schematics. And now I'll be explaining the working of this hydraulic circuit. So first is the hydraulic fluid flow path, which takes from the hydraulic reference and customize the hydraulic fluid taken to the motor and then to the pump. So ensuring that the variable flow rate occurring and the required has been set up in the Simulink model. So next is the pump operation and its influence. So here we are ensuring that the pump generates a flow towards the accumulator through orifice when the orifice is open, and this ensures that the pressure is being raised in the accumulator to a maximum of 10 bar as per the given schematics. And now the orifice, once the accumulator has reached its maximum pressure, the orifice is being closed and now it has been disconnected from the pump. So orifice is used as a pump failure scenario or a simulation, you can say. So then now since the pump has not been generated a flow, so the accumulator is used to ensure that the loading and unloading or retracting has been occurred. So now the accumulator flows from the flows from the accumulator to the piston, generating a unloading condition. So there is a variation in the flow rate which is occurred in the graph, which I'll be showing next. The flow once it is once the accumulator is being flown to this piston and the unloading condition occurs. So the circuit is being completed after the operation is done and then sent to the hydraulic reference till the simulation is running. So now I'll be showing you the hydraulic circuit in the Simulink model. So this is the Simulink model which I've been showing here. So now I'll just run this program to see how the simulation is being occurred. And for each of the Simulink model, I have given us a scope to visualize the graphs. So this is the flow rate from the accumulator. So I've used a cycle for every 2 seconds and giving a delay of 4 seconds for the charging purpose. So till 1 second, it has been common. There is no flow rate since it's been charged already. And now after 2 seconds, there is a negative flow rate which has been occurred. You can see it now. There's a negative flow rate which ensures that the flow rate is occurring from the accumulator towards the piston. So this occurs for the every 4 seconds now. Now the piston displacement. So initially it's been 0, and when the flow from accumulator towards the piston occurs, it increases to 0.1 meters, and then it retracts very slowly towards 0 after a few seconds. Next is the accumulator pressure variation. So this is the pressure. Once it is charged, it is increased to a maximum, and then it turns to zero when the flow has been released. Can see it. So these are the results which have been obtained. And now for the conclusion. So the simulation effectively captures the behavior of a pump failure simulated by the presence of orifice in the circuit. So when the pump is disconnected, the negative flow rate from the accumulator signifies the stored pressure to facilitate both the extension and the retraction of the position, loading and unloading. So this observation highlights the crucial role of an accumulator in maintaining system functionality in absence of a pump. So these types of accumulators are used mainly in the bigger machineries, or even the particularly in aircrafts when they require a higher pressure for the wings, etc. That's it. Thank you.